In this video, we're going to talk about valence electrons. Now, what are valence electrons? Valence electrons are really a special type of electrons, and the reason why we care so much about valence electrons is because they're the ones that are usually responsible for chemical reactions. Okay, and so I'm going to draw a Bohr's diagram so that way you can see which ones are the valence electrons. So if this is my nucleus here, all right, and these are my orbitals. This case, this one has two shells, right? My valence electrons are electrons in the outermost shell. All right, so in this case, is this electron here? That's my valence electron. All right, and so it's just your electrons in your outermost shell or outermost energy level. Okay, and so there's a couple of ways you could actually figure out how many valence electrons a particular atom have. All right, and so the first way, which is the longer way, I'm going to start with that one. You could use electron configurations. Okay, so for example, if we have, let's talk about the electron configuration of calcium, right? The electron configuration of calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. All right, so this is the electron configuration of calcium. Now, if I were to ask you, okay, how many valence electrons does this atom have, based off the information that's given to you? Now, remember, valence electrons are electrons that reside in the outermost energy level or the outermost shell. Okay, and so how can we figure out from this by looking at this electron configuration? Remember, these numbers here represent the shell, right? So 1, 2, 2, 3, 3, 4. The outermost shell is the one with the largest number, right? And so the one with the largest number in this case is your 4. All right, and so how many electrons do we have that resides in the fourth shell? 2. All right, so in this case, calcium contains 2 valence electrons. Okay, so that's how you'll figure this out. Let's do another example. So let's consider the atom sulfur. All right, so sulfur, all right, has 16. The neutral atom has 16 electrons in this case. So sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. Okay, so now we need to figure out, all right, how many valence electrons does the atom of sulfur contain? Okay, so now when we're looking at this, we need to find the highest shell, all right, the highest energy shell in this case. And so we have 1, 2, 3, 2, 2, and here's your 3s. So in this case, the highest energy shell is 3, right? And then we need to add up, or we need to count how many electrons we have in the third shell. All right, and so if you notice, we have 2 over here, and we have a 4 over here. And so that now that we know that, so we will add this up. So how many valence electrons do we have here for this atom of sulfur? Well, we have 6 valence electrons because there are 6 electrons in the third shell, or the third energy shell. All right. So let's look at another example. All right. So let's talk about iron. So iron here has 26 electrons. So its electron configuration, and let's do the long one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then we have 3d6. All right, and so the question is, how many valence electrons does the atom of iron contain? All right, now keep in mind of the definition of valence electrons. Valence electrons are electrons in the highest shell, energy shell. Okay, and so when we're looking at which one is the highest energy shell, here's 1, 2, 2, 3, 3, 4, 3. All right, which one is the highest energy shell? Well, the one that's the highest energy shell is your highest number. The highest number is 4. All right, and so how many electrons do you have in there? Well, we got 2. So in this case, we have 2 valence electrons. All right. And so I just want to make sure you just do not get that confused. Make sure you kind of just pay attention to when you have the electron configurations, always look for the highest energy shell. And then you count up how many electrons are within that shell. Not necessarily how many electrons are in the sub shells specifically, because if you have, in this case, like, you know, we had earlier where you had 2 third energy shells, and you had the S and the P sub shells, you had to add up all the electrons that were in both those sub shells. Okay, so we have to look at the shells specifically. Okay, so now let's look at another way that we could figure out how many valence electrons a particular atom has. And I think this is the easier way to figure this out. All right. So another way that we could figure this out is just by looking at the periodic table. Now, depending on what column it's the elements in, actually determines how many electrons, how many valence electrons it has. All right, and we could go into kind of detail about this, so that way you could kind of see exactly what I'm talking about. All right, but so I guess let me just go ahead and explain the kind of the theory behind it. So I'm going to start on this side, on the left side here. All right, so this side we have what we call the alkali metal. So that's lithium, sodium, potassium, rubidium, cesium, francium. All right, and so let's kind of look at each of them. And why do all of these elements in the same column have the same number of valence electrons? All right, and so let's look at the first one, hydrogen here. Hydrogen, its electron configuration is simply 1s1. How many valence electrons? Well, there's 1 valence electron. Okay, let's look at lithium. All right, lithium, its electron configuration is 1s2, 2, that's not a 2, that's an S, 2 S1. All right, highest energy level or highest shell, energy shell. All right, and how many electrons are in there? Well, there's only 1 valence electron. So lithium has 1 valence electron. Let's look at sodium, Na, 1s2, 2s2, 2p6, 3s1. All right, and so if you notice here, hopefully you start seeing this trend, that you only have 1 valence electrons. Let's look at potassium. All right, so for potassium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. All right, and so if you see here, there are only 1 valence electrons. And same is true for rubidium. All right, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1. So once again, if you look at here, there's only 1 valence electrons. So I mean, I could continue going, but I think you guys kind of get the point that in this first column here, these elements all have 1 valence electron. Okay. And so now if we're moving on, and just to kind of show you the trend, the second column here, they all have 2 valence electrons. Okay. Now the transition metals, it kind of varies. It varies between 1 or 2 valence electrons. All right. I mean, it just really kind of depends on the electron configuration there. So don't really worry too much about the transition metals. But when we get to this, the boron group or boron column here, they have 3 valence electrons. Carbon group has 4 valence electrons. Nitrogen has 5 valence electrons, or the nitrogen group. The oxygen group, or the oxygen column, has 6 valence electrons. This one has 7 valence electrons. And then when we're going this side, just to kind of be careful on is that from neon down, they have 8 valence electrons. Helium has 2. All right. And so that's kind of like the exception to this rule here. You just got to really be careful. Helium only has 2 protons. If it's neutral, it's going to have 2 electrons. It's not going to have 8. So you just have to remember that. But neon down all have 8 valence electrons. And so by just looking at what column they are in, you could easily tell and determine how many valence electrons that particular substance have. Okay. Now, We also notate in a picture format the amount of valence electrons something has. All right, and this picture format we simply call a electron dot symbol, or sometimes it's called a Lewis dot symbol. Okay, so they're both are the same. All right, and basically what you're doing is that you're going to write the symbol of the element, and you will basically also draw the number of valence electrons as dots around that symbol itself. And so let me kind of show you what I mean by that. So lithium, all right. So let's look at this periodic table here. So if you look at lithium, lithium is here. All right, so we see that lithium has one valence electron. So the Lewis dot symbol of lithium, or electron dot symbol of lithium, is that you will take lithium and you want to draw one dot. That's it, to show the fact that it only has one valence electron. Okay, let's move on over. So let's look at beryllium. All right, beryllium here we see there's two valence electrons. All right, and so I'm gonna write beryllium, okay, and I'm gonna draw its two valence electrons. Now typically kind of the rule of thumb with this one is that you kind of have like four sides to the symbol. You got the top, right, bottom, and left of the symbol. And much like the electrons in the orbital diagrams, we typically stay away from doubling or putting two electrons in the same side until all four sides have an electron first. So in this case, what I mean by that, since beryllium has two valence electrons, I'm gonna put one here and I'm gonna put one on the other side, something like that. Okay, that way we don't have two all on the same side. Let's look at another example. So let's say we want to write the orbital diagram the Lewis dot symbol for aluminum, right? Aluminum has three valence electrons. So what I'm going to do, I'm going to write aluminum, and I'm going to draw three dots. Simple as that, okay? What about, I don't know, it's like a silicone, right? Silicone, four valence electrons. So it should have four dots, right? So Si, 1, 2, 3, 4. Hopefully you're kind of getting the gist of this. Let's do more for the sake of just doing more. I guess I don't want this video to be too short, just add some more time. So we have nitrogen. Nitrogen has 5 valence electrons. All right, so we have nitrogen. All right, and so we're going to draw 5 dots. And usually what I tend to do, I just draw one on each side and then I double if I need to. So 1, 2, 3, 4, and here is me doubling. So here's the Lewis dot symbol for nitrogen. Oxygen, or let's not do oxygen. Let's try something different. Selenium. Here's selenium right here. 6 valence electrons. All right, so Se, 1, 2, 3, 4, 5, 6. All right, there's my 6 electrons here. What about iodine? Let's look at iodine here. Iodine's right there, has 7 valence electrons. So I'm gonna have my I, 1, 2, 3, 4, 5, 6, 7. So here's iodine with 7 valence electrons. And then let's go big. Let's go radon. All right, so radon has 8 valence electrons, like written here. So radon, 1, 2, 3, 4, 5, 6, 7, 8. So this is the way you draw the Lewis dot symbol, or the electron dot symbol of an element. And so remember, the electron dot symbol just only represents in the symbolic form how many valence electrons it has.